This video tutorial assumes that you've already installed the requirements at the top of the page. So we'll start with downloading the necessary Git repos. The first one is the example FastQC app. The next is the FastQC router reactor. And the third one is the Python scripts for creating notifications. So we'll start with the reactor. There's three files that you'll need to change: the reactor RC, reactor py, and the config.yml. The only field you need to change in the reactor RC is your Docker Hub username. You can also change the alias and the version of the reactor you'd like to deploy, but that's not necessary. So the Docker file is pretty simple. It pulls from a base image. This is currently hosted on my Docker Hub, but in the future we'll have either a Cyverse or an iPlant Docker Hub to pull from. Next, in the config.yml, this is basically a dictionary that gets imported into Python, and this is a job description for the FastQC app. It has all the necessary fields that you need to submit a job, like app ID, job name, and then the archive system and archive path, and the inputs get defined when the reactor actually executes. So let's get into the reactor.py, which is the Python script that will actually run when the reactor is executed. You need to import a couple of libraries. These are included in the base image. Import reactor and Agave utils from reactor utils. Import copy and JSON because we need those. And now let's take a look at the main function to see what happens when the reactor runs. First, you import the reactor environment, r equals reactor. There's a couple logging messages, and then r.context includes information that gets passed to the reactor by the notification service. And so it is also a dictionary. In the message there's a little bit of parsing here to pull out the information that we want. There's a file field, and in the file field we have system and path, which is what we need to run the FastQC app. I've printed some of the fields out here so that you can see what they look like. And there's a little bit of checking to make sure that we aren't executing on the output of FastQC when it gets uploaded to this directory. And then the submit function gets executed. And you pass that the reactor, the system ID, and the path. This creates a client, AG equals the reactor client, and it creates a job definition. And that job definition copies the information from config.yaml, and it redefines the inputs, which is going to be the FastQ file that gets uploaded to the directory. It defines the archive system, and then also the archive path. And so to define the archive path, I've just split the actual file name off of the path, and then it will upload the output to a directory called analyzed, which is in the same place as the FastQ file that was uploaded. Now that it has the job definition, it goes ahead and submits that with AG jobs submit. It submits the body, and then it prints out the job definition. If there is an error with your job definition, it'll print out the error in the job definition to help you figure out why. Now your reactor is all set up, and all you need to do is deploy it. And you can do that with the command Abaco deploy. This builds the Docker container and pushes it to the repo in your reactor RC. After it's finished running, it will return a actor ID. You'll pass this ID to the notification script to set up a notification. And you can do that by typing Python add notify reactor.py, which is the Python script, the system name. In this case, I'm using data iplantcollaborative.org, the path to the directory that you'd like to set up a notification for. In this case, my username, Urrutia, and then FastQC, which is a directory I made for this example. And then finally, the actor ID. If this runs successfully, it'll return a notification ID and a notification URL. The URL contains your actor ID and a nonce callback. The nonce is essentially a token. You can find more information about the notification by typing notifications list-v and then the notification ID. You can see that this one is set up to notify us of any event. Now we're ready to test that the analysis gets triggered off of a file upload. So I will just copy a example file here, reads1 fastq.gz. I'm going to list my destination directory to make sure that there's no files in there yet. Nothing there. And so now I'm going to go ahead and upload the fastq file. The upload looks successful. I'll just double check. And the file has landed. So now a notification should get sent to the reactor. I'll check to see if the reactor has been executed by typing Abaco executions -v for verbose output, followed by the actor ID. And it looks like we have executions for this actor. So let's take a look at the execution log for one of these executions. To make this easier, I'll just go ahead and assign environment variables for the actor ID and the execution ID, and then type Abaco logs actor ID execution ID. Okay, and it seems to have run successfully. This is the job submission JSON that it prints at the end. This is the reactor context that it prints in the main function. Just pull that up again here. So here's where it prints the context. This is where it prints that files attribute. And then finally it prints the system and the path. Read1 fastq gets trimmed off the end, and the archive path gets set to the same location in a subdirectory called analyzed. So let's run jobs list to see if the job is running. It looks like the job is successfully running. After the job has finished running, we can look at the outputs by typing files list and looking at our directory. You see the analyzed folder has popped up here. That's where it archives the analyzed data. So let's take a look and see what's in that folder. There's some log files and then the output of fastqc, which is an HTML file. So I'll go ahead and download that file with a files get. That pulls it from the remote storage system to my local computer. And now let's take a look at the output in a browser. So I'll pull up read1 fastqc.html in my Chrome browser, and we see a pretty standard fastqc report. Hopefully this tutorial is useful for you to automate your analyses. There's no reason why you have to stop at one app. You can chain together multiple apps into a workflow. So after fastqc, it could get sent to Trimmomatic, some alignment tool like star. Pretty much any workflow you can imagine can be automated in this way. Thanks, and good luck.